All right. Now we're doing 6Q Season 2. Does my number look big in this? Or maybe more like this. Does my number look big in this? Something like that. Anyway, so this is by Julie Nichols, and 92% of the people like it. So a narcissistic number, or Armstrong number, is a positive number a positive number which is the sum of its own digits, each raised to the power of the number of digits in a given base. In this kata, we will restrict ourselves to decimal, so base 10, all right? So for example, take 153, 3 digits, which is narcissistic, I should say. So 1 cubed plus 5 cubed plus 3 cubed is 1 plus 125 plus 27, which equals 153, which is this number. Awesome. This one, 1652, isn't, because 1 to the 4th plus 6 to the 4th plus 5 to the 4th plus 2 to the 4th equals 1 plus 1296 plus 625 plus 16, which equals 1938, like that, which is not that number. So, the challenge. Our code must return true or false, not true and false, as in, like, I'm pretty sure this person's talking about strings, depending on whether the given number is a narcissistic number in base 10. Pardon me. This may be true and false in our language. For example, ergo PHP. Well, it's not, because we're using JavaScript. All right, so error checking for text strings or other invalid inputs is not required. Only valid positive non-zero integers will be passed into the function. Okay, so first thing we're going to do here, first thing I'm going to do, you can do whatever you want. First thing I'm going to do is say const narcissistic equals, and then we're going to get rid of this. In fact, I'm going to get rid of value altogether and just turn it into v, and then have an arrow right here. We're going to do an arrow function syntax because it's easier, in my opinion, to test by saying console.log like that, and then just test as we go. So now let's check v, test it out, just to see what it looks like right now. All right, right now it's 7 and 122. I don't like that. 7 is too easy. Let's make it this 153 by deleting all this from here to here, just like thus. Test it out again. All right, now we can use 153. This is much better to look at. So what we're going to have to do first is we're going to have to separate each one of these digits and put them into an array where each one is in its own element. But to do that, we can't just do it with digits. That's not how this thing works. So we're going to have to turn this thing into a string. All right? So how do we do that? We should know by now, just like thus. Test it out. It still fit 153. Let's do a type of. Test it out. And look, it's a number. Oh yeah, because we didn't put this in parentheses. But type of basically will tell us if it's a number, string, or whatever. So let's put this in parentheses like this, just for a second, test it out, and thus it's a string. All right, so let's do a control Z, 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 like that, get it back to this. Now we've got this, what we want to do is put each one of these digits in its own element inside of an array. So we're just going to do an array literal right here, by doing this and putting spread syntax in front of it, the 3 dots. If you don't know about spread syntax, it's right here. It's a really, really nice trick to make this into this, all right? So now we've got each one of these in its own element. So what we're gonna do is do each one of these to the power of whatever the length of this is, all right? So for that, we're gonna use the reduce method, .reduce. I've done a bunch of reduce kata so far, so you can check those out if you're not really too sure about it. But here's reduce right here, and they've actually changed it up a lot. This is horrible syntax. This is horrible right here. I don't even know what's going on right here. But I do suggest checking out any of my other videos with reduce in it, because it has the old style. They all have the old style of how this used to look, and it's so much easier to read. So we got reduce. What we're going to do here is R for results. So like if we were doing a for loop and we had result equals 0 at the beginning. So we got R for result right there. We've got the E for the current element. So this element, and this element when it does the reduce in order. Then we've also got the I, but we're not going to do the index because we don't need it. So we'll just have an underscore to let us know that we're not going to use it. And we're also going to use the A for the array. So it targets this array right here. All right, so what we're going to do here is we're going to say R plus, space that over, we're going to say R plus E to the A dot length power. All right, so this dot length, whatever it is, it's going to do the current index times that and then add it all to the result, which the initial value of the result is 0, not O, 0 right there. And you can learn all this in the reduce right there. So let's see what this looks like. Oh yeah, don't forget this arrow right here to make it an arrow function. You see the colors are there now and it's looking good. So let's test it out, see what happens. And look, we got 153, we got 17, and we know that when you multiply a string times a number, it turns into a number. Numbers take precedence over strings. I guess that's what the deal is. So now we've got 153 and 17. We need this to equal 122. We need this to equal 153. So let's just say equals V. Test it out. True, false. Looks good. Let's make sure there's no tricks. Test it one more time after the console.log is taken out of there. Look at that. All right, attempt it. Oh, let's hope. All right, and there we go. And that's a nice little 6Q. I remember when these were much harder for me back when I was doing them earlier, but it turns out practice does get you through the levels. Let's submit it. And come on. I mean, you can see video evidence of me struggling with these bad boys. So, I mean, the proof is in the pudding. You keep working after a while, even 6Q gets easy. So we've got this right here where they're doing the split and the reduce right here like we did. They're using the normal syntax instead of the concise syntax like we used. But it's basically the exact same thing we used right here. This one, basically, they're mapping it and then they're reducing it. They're doing the, what is it? The you know what I'm saying. You can see this. They're doing the element being cubed or whatever to the r.length power in this one. Anyway, so let's just say, let's throw some clevers on these two. Let's not be jerks. Clever. And here's a while loop. Nice. Digit.push remain, blah, 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 blah. You can check that out if you like while loops. There's one. So let's go over to mine. Okay, just me on this one. Best practice in my opinion. Very much like it. And we'll see you next time.